Hi folks, hi folks, Sid here from Border Archery. Several people have asked me about riser lengths, why choose a riser length. So let's try and get into some of the geometric issues of riser length. But first off, I think for riser length you have to talk about bow length and what bow length means. Um, Limbs, as far as we're concerned, limbs are related to draw length. So the limb length should be related to your draw length. Short limbs, short draw, long limbs, long draw, medium limbs, medium draw. We do extra short, short, medium, long, extra long. And that's because we try to optimize the, and I hate that word, optimize, the draw length. I think it's an overused word in marketing departments to claim that they haven't got enough of something, optimized torsional stability, yeah, whatever. Optimized draw length is quite a simple one because your draw length is your draw length. I can't change that. So what I can do is I can try and get the best out of a limb for your draw length. That's not necessarily 100% solely dictated by the draw force curve. There are other aspects of limb design that can be manipulated, to perform better. So if you try and take a short limb and draw it to a long draw, it's as good as broken. So don't do it. Glass fiber's incredibly elastic. Carbon fiber's not elastic, so you won't get away with it. So when people say that border limbs are draw length sensitive, the drone of the negativity is horrendous. Draw lengths are sensitive on any properly designed carbon limb. I'm not talking about a carbon limb that's actually a glass limb with some carbon in it. I'm talking about a dedicated carbon limb. There's a reason why other brands are not allowing their full carbon limbs to be used on a couple of models of riser. The adjustability in the pockets is just absurd. Right? So what we try and do is we try and get performance that's optimal for your draw length. So the next one is short bows open up faster than longer bows. All right, 28-inch draw length, for example, if you had a 28-inch bow, would be a 1-to-1 ratio. If you double the bow length, then the bow length is twice that of the draw length, which means it's going to be a slower process. Yeah, a 72-inch bow to 24 inches doesn't really make much sense. So what we talk about is the working material of the bow. That's an in-house term, which would be from the fade out to the tip of the limb to the string. Those parts are the parts that deliver your draw length. Now, can a shorter bow use the same limb? Yes, it can. What you end up having to do is to back the limbs off a little to relax the design to be able to accommodate that rapid opening. There's a downside to that, is you end up losing a lot of the preload, the performance of the limb. So there's a compromise to be had, and any manufacturer that just uses the same limb pad angle across the range is kind of doing the bow a disservice. If that was the case, I'd be wanting the limbs to be drawn shorter. 26 for a medium limb, for example. And the way to do a rough estimation is the poundage gained. So if you take your 2 pounds per inch ruling, the normal conventional limb, for you draw the bow back another inch, it'll gain 2 pounds. If you think of a short limb is meant to go up to about 28 and a quarter, right, at the top end, designed for 27s really, would you expect that limb to gain 7-8 pounds of draw weight? At 2 pounds per inch, 8 pounds is 4 inches more draw than 28. You wouldn't expect a short limb to last. whereas you would with a long limb. An extra long. It's not really designed to be shot at 28, it's designed to be shot from 30 upwards, right? But it's measured at 28, so therefore you could expect it to do 4 inches more, right? So there's a bit of fun. Anyway, riser length. That's the bow length. Now, one of the things about bow length, by the way, is your face characteristics. When you come to anchor, the string will come off and you'll have certain contact points that you know, eyebrows, whatever your anchor is. There'll be string alignment contacts that you would know. So changing your bow length would change those contact points. That's one aspect of bow length that gets a bit messy. But we would recommend riser length. Now, one of the basic rules is longer limbs, they store more energy than short limbs. You can do more with the shape as a bowyer. So longer working limbs can do more for you. Short working limbs generally stack more with soft stack though. Let off, how can that be classed as stack? But anyway. So the next conundrum is window length. Now, some of the extended limb butt length model risers, you end up having to go a riser up to achieve what you needed to achieve, and it's all based on a simple idea. First off, if you want to shoot at the target and you have to aim higher, you now can't see the target because your hand's in the way. See, it's obliterating my beautiful face. So the next part is that once it's in the way, that the other way to get the shot angle, rather than lifting the front to get that shot angle, you can drop the back. Okay, so what you'd end up getting is a tab with a platform on it to get your anchor off your jaw with a bit of a spacer to get lower, so that when you lift your hand at 90 meters, you can achieve the shot, yeah, without obscuring the target. There's a downside to that, and that is when you bring the targets right into 18 meters, you end up with a problem that it looks like the arrow's pointing at the ground, and it looks particularly weird. It's not so bad if you've got a sight, but if you're aiming off the point of the arrow, it starts to look really quite bizarre. It gets hard to aim because you get nothing to aim at. So that's because your anchor's all the way down here, and I brought this along. So what you end up with is, let's see if I can draw this sideways. What you end up with is your eyeball, your pupil, right? And then you've got your nock, right? So the idea is that everything shoots flat for the first 12 yards. For the sake of argument, it's flat, right? The arrow hasn't really dropped anything, but it's travelled far. That's because the arrow's fastest as soon as it leaves the bow, and it hasn't started dropping yet. Okay, there's some physics in it, but I'll cut to the chase, right? So what you're looking for is something called parallel vision to the target. Okay, now what you're actually seeing is the point of the arrow, right? You're actually looking down at the dirt whilst the target, I'm quite impressed with myself here, by the way. Yeah, I'm looking at the camera while I was drawing backwards. Right, so you're looking at the target. Now, okay, it's not this big a difference because you're talking that, right? But what happens is the arrow will travel parallel to your vision for the first 12-15 meters, right? So that means that for the 18-meter shots, it feels like you're pointing down at the ground whilst aiming at the target. So what you find is that the size of the window, 25-inch Tempest here, the size of the window, right, is, you see, there's the arrow down at the low end, right? The size of the window is from your nock down here to your eye up here, right? That allows you to get right down. So that's the size of the window that's required. Now, for example, if you're a hunter, you're probably not wanting to take shots more than 20 yards. So if you're shooting 20 yards or less, 12 to 8 for example, 20 yards is close to 18, 15 meters. It's kind of flat. It really hasn't started dropping badly, because what you'll notice is if you were to shoot flat to the ground, parallel to the ground, your arrow would do that. Yeah. So it's flat, 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 and it starts to drop, and then it starts to drop badly. So the 70 to 90 meters is chronic in terms of the angle that you have to shoot at. It's there, 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 then there. You know, really having to throw the arrows in. So if you're not shooting, more than 20 yards, then you're shooting pretty much in this flat spot, right? Which means you've got this absolutely fantastic bit where you can pull your anchor up to your eye, which means, because you're not having to lift your hand or drop your hand, you can lift it up, which means you can end up accommodating quite a short window, which is why you can get away with shorter risers, right? 19-inch. So there's the reason why you would go for a longer riser, shorter riser, because number one, it changes the string angles, but number two, it gives you the window that's big enough for what you're looking to achieve. Right? Now, let's go back to this. If your bow is fast with a reasonable weight of arrow, I'm not talking about a shuttlecock that comes out really quick and then dies really quick, right? 90 meters might be there, in which case you're not having to shoot as high. If you've got a really, really fast bow, then in effect you can accommodate a shorter sight window. Yeah? Because you're not having to lift as much, or you're not having to drop down as much. You don't need a platform. And that's one of the reasons why your weekend warrior that's not particularly archery fit, doesn't want to shoot 50 pounds, has got a particularly short draw length, for example 26, 27 inches, it's why they would struggle with a 23-inch riser if they were shooting full target, because they don't have the window size. Yeah. Now obviously if you want to put the balance point of the riser where you want it, then to have this amount of space you need to have it down there, therefore the riser ends up 25 inches long. If you put your limb bolt into there, you've lost your window space. You have to run the 27-inch riser. See what I mean? Now, there are other things to try and consider. Longer risers allow you to move the mass further out. And if you move the mass further out, you end up with an advantage there. For example, if you're string walking though, that can give you a bit of a problem, because some of the things that will ease the asymmetry in the draw is having longer limbs. But also, as I say, what accredits the draw length is both the string, the working material, the string, and the limb length. So they help to accommodate that asymmetry in a crawl. So with string walkers, you don't necessarily want a longer riser. Yeah, and there's a bit of a reason for that, is because it allows you to run that next limb size up. Now, with a bow with a smooth point at about 19-20 inches, i.e. a conventional limb, then as you pull it back, you're not going to see much difference in efficiency between a medium and a long limb, so don't worry about that one. It starts to get different, and I'll make an analogy to a compound. With a really big recurve, a super recurve, there's no point in going for a longer limb if you don't have the draw length, because you won't get it into that smooth point. You won't get it to the let off, for the sake of a term, and that's where there's just no point in buying the longer limb than you need. Okay, so that's the rationale on that. Now you'll notice there's no stabilizer bushings on the 19. There isn't on the 21 Tempest, and there isn't on the 17-inch Tempest. And one of the reasons for that is the rough rule is twice the mass at half the distance has the same resistance to movement. Yeah, so to get the same resistance of movement on a 25 as you would a 17, you'd have to have a heck of a mass on the ends. But if you can get the mass further out, right, then it adds as a bonus. So from the stabilizer bushing to the limb bolt is about 1 inch, yeah, and that gives you a funky change, because what you can effectively do is, for a normal riser which doesn't have the stabilizer bushes, you will have, hi, I'm back, maximum time recording exceeded, what the heck, anyway, okay, so if you can half the mass at twice the distance, right? So the longer, the more spread out it is, the more effective it becomes for any set amount of mass. So what I'm recommending is that for the shorter risers, you move the weight out 1 inch. So in effect, the 19 is like a normal riser's 21, because you've moved the mass further out. Now, we've actually got some quirks. We've got some features that I don't think most people realise. Right, let me just get this bow here, one that I've had lurking in the background. This bow doesn't come with any stabiliser bushings out there, apart from like for a fishing reel, for example. But our limb bolts, yeah, our limb bolts, our floating head limb bolts that sit flat with the limbs. You can get them that take bushings. You can get them in stainless steel. There you go. Or you can get them in black oxide. Yeah, so you can add weight to your bow. What that does, for example, with the likes of this model, is it it allows the bow to balance better. Yeah, there's 200 gram, 100 gram. You can do 100, 100. We do 100, 200, 300, and 400, and get the bow to balance better, because the D-flex, all the pockets are all back there. These pieces of the pocket are back here, so it's going to want to fall over. All right. So yeah, riser, mass distribution, moving it out, window size, bow length, they're all features that need to be considered. All right. Hope that helps. It's all to do with that flat shooting. It's all to do with the distance that you want to shoot over and the speed of your bow. If you've got a fast bow, the distance becomes less important, in which case the window can get smaller. If you're shooting over a wide range of distances with a fixed anchor location, you need a big sight window. Otherwise you can change your anchor, which is face walking. Lots going on there. All right? Yeah? Again, questions, ping them in the comments and I'll do my best to answer them. All right? Thanks for watching.